Hello and welcome. My name is Morgan Bailey. I'm the Head of Communications here at Rocket Lab, and thank you so much for joining us here today. Next to me is a familiar face to many of you. This is our founder and CEO, Peter Beck. Hi, Peter.
Hey, Morgan.
Well, today we're here because typically this time of year we are in beautiful Logan, Utah, celebrating the SmallSat conference with all of the fantastic people in this space industry. And unfortunately, we can't be there this year, just like everybody else. But we didn't want to miss out on catching up with everyone, so we thought this would be the next best thing. So SmallSat's got a really special place in the heart of our team, and so we wanted to give everyone the opportunity to catch up with us, to hear some questions and share a bit about what we've been up to since this time last year. So with that, I'm going to hand over to Peter, who's going to give us a bit of an update on some pretty exciting things, and towards the end we'll have some Q&A from everyone.
Thanks, Morgan. And as Morgan said, the one thing I love about SmallSat is getting to Utah and being able to walk around, see everybody in their booths and at the parties and just catch up on general things. People generally have lots of questions for me. I have lots of questions for them, and it's one of the truly special things about SmallSat is that community. So as Morgan said, this is the next best thing, excuse me, that we could come up with. So we're looking forward to interfacing with everybody and hearing everybody's questions. But before we go to that, I think it's appropriate to give a little bit of an update. This time last year we were stood at SmallSat and made the announcement of recovery, and that was a pretty big announcement for us and resulted in some hat-eating activities. But a year's passed now, and we've made huge progress. And this is a project that's personally run by me. I'm really passionate about it, and it's great. It's almost the only real engineering I get to do anymore. So it's huge fun. And if we look at recovery, we kind of broke it up into three separate chunks. And they're kind of the three areas that we needed to demonstrate, in the three areas that are really, really hard. And we tackled the hardest thing first. Re-entering a stage through the atmosphere, or through the wall as we called it, was technically by far the hardest thing to do. And we very quickly were able to build a stage. We put reaction control thrusters on it. We built a whole avionics package, guidance package, a whole new flight computer in GNC, IMUs, everything, instrumentation, S-band radio links. We built tracking stations, additional tracking stations. We had aircraft in the sky also tracking. It was a logistical, piece of work. But we successfully re-entered 2 stages in a row, and that was a huge milestone for the recovery program, because not only did we re-enter them in a row, we re-entered them relatively consistently. We got fantastic data all the way to ocean impact, and it really put us in a strong position to move forward with the next phase. And then kind of the next hard thing was, it looks like we should be able to capture this out of the sky with a helicopter. Historically it's been done, but actually, physically how hard was that to do? So that was another piece of work, and then earlier this year we dropped a dummy stage out of the sky and came back around and hooked it under the helicopter, and it was first time.
It was pretty spectacular.
Yeah, no, it was a great near helicopter pilot made it look easy, but he was certainly working for it. But it was that was an important thing to validate that was all doable, and we felt comfortable and confident with that. And then the final stage is getting it under a parachute and decelerating it, and actually getting one back in the factory. So we said the recovery team this year, we said, right, we want to get one back in the factory this year. Doesn't really matter what condition it's in, let's just get one back in the factory. So the next stage, which is Flight 17, is where we'll actually go and that whole flight has got the whole parachute recovery systems. But in order for us to validate the parachute element of this, and we have to decelerate from a relatively high Mach number to a sedate 10 meters a second before we splash down in the ocean, we had to validate all our parachute systems. So Rocket Lab designed all of these parachute systems in-house. Lucas is in charge of that in the recovery team, and did an incredible job of designing all the parachutes from scratch. There was nothing there that really met our timeframes or our requirements. So in the end, we just sucked it in-house and did did it internally. And parachutes are very, very tricky things. So a couple of days ago, in fact yesterday and the day before, we did kind of the final test before we're ready to go and fly Flight 17, and that's where we basically simulate the highest load case, where we drop a fully weighted dummy stage out of the sky and accelerate it to the highest load point, and then pop the canopy. So I think we've got a cool little video here. So cue the video and you can see the results of that test. Wasn't that awesome? It was a super fun day, and it's great to get let out of the office and actually do real work. It was an awesome day, and there's nothing like making thunderclaps in the sky with 1.2 tons of stage re-entering at 0.3 times the speed of sound. It was really awesome.
Well, we lost you for a couple of days down to the launch site.
I know, it was great.
I heard a rumour that you slept on, was it the floor of the vehicle hangar, or?
No, I mean, on the floor of the customer room. It had
slightly more
carpet.
comfortable.
It's slightly more comfortable. Yeah, but no, it was awesome. We were able to get a couple of parachutes, drop tests away, and repack the chutes over the night. So the team, we really busted hard to get those out. And look, the results speak for themselves. It was wonderful deployments, and that really is the final sign-off before we're ready to go and fly Flight 17. We simulated all the worst load cases, and we're ready to go. And Flight 17 is sitting in the factory there. I'll tweet some photos of some of the interstage stuff. It looks really cool to see all the parachute hard points and some of the recovery systems in there. It's just looking awesome. So very excited to get that. And the objective of Flight 17 is to not scoop it with the helicopter. It's just to get it in the ocean, and we'll fish it out of the ocean, bring it back, put it in the factory, and then we'll really see what we've got. That will determine how much work we've got ahead of us. To date, the telemetry would say that we've got a pretty healthy stage, but that's where the rubber meets the road. So that's a quick recovery update. And obviously there's lots of other stuff going on. Some of you may have seen that we have increased the performance of Electron a little bit. And that was
just a touch.
Just a touch, yeah, well, a decent chunk actually. But that was really enabled by an increase in battery technology. When we first started the Electron program, batteries had a certain baseline, and that technology, as we predicted, continued to improve. So we've really been able to take advantage of that with the performance. Obviously the spacecraft division is growing incredibly strongly. And I've got my mission photons T-shirt on here. So this is our Photon spacecraft to the moon and ultimately on at some point to Venus. So there's lots of cool stuff going on, and of course LC2 is really spooling up as well, and we're getting ready for that launch coming up really soon. I think we might actually have a cool video about that as well. So if you want to play that.
Yeah, I cannot wait for the first mission from LC2. We've been through 13 now from LC1. It feels like home. It is Electron's first home, but now to be, launching on the other side of the world and collaborating with the incredible teams at NASA and, of course, at Virginia Space as well, has just been a phenomenal experience. And I'm so excited to get this one off the pad.
Oh, look, me too. And the really exciting thing about LC2 is, yes, it's a launch pad, but it's much more than a launch pad. We've got a whole integration facility that's got multiple clean rooms. We can have 2 Electrons on standby ready to go and up in the capacity up to 4. And this is really true responsive access to space. This whole launch site and this whole capability was born there to really deal with true access to access to space, rapid response. It's all good and well to have a rocket on the back of a truck, but you've still got to move a truck around, and there's a lot of logistics. So
a lot of licensing and FAA regulations as well, safety zones, all of that.
Yeah. So if you get, you might get the call, hey, we need to go and launch, and then you got to go and assemble a logistical fleet of trucks and move them around, or aircraft, or whatever you need to do, or half a mile and you roll it out to the pad and go. So.
Exactly.
So that's what I'm excited most about LC2 is that true rapid response to space. So, I don't want to gabble on about all the stuff too much longer, so the whole point of this is...
We could spend all day. We've been busy this year.
The whole point of this is to allow anybody to ask any question they wish, so and happy to answer it. So.
I will draw through some questions. We're going to do our best to get through as many as we can, so go easy on us. But let's see what we can do. All right, so first up, question asked quite a while back now, but what's the draw for Venus? Why is that kind of front and centre for you?
Oh, I love Venus. No, I'm madly in love with Venus. So Mars is super interesting, and Mars has got a lot of attention because Mars is a planet that, we will put a human footprint on Mars. I've got absolutely no fuzz on that. That will happen. And that's incredibly motivating and exciting.
Yes.
But if you look through the solar system, there are three probable candidates where life may have existed or even may still exist in some form. And one of those is Venus. And the other thing I love about Venus is the closest analogue to Earth. Venus is Earth in a climate change disaster. Yeah. If we keep on a trajectory, we're just going to end up with Venus. So there's a lot to learn about our own planet from Venus. But if going back to the probability of life, I think that is at least for me, one of the biggest questions that there is. Are we alone in this universe? Is life prolific or incredibly unique? And there's a very, very interesting place in Venus's atmosphere. It's about a 50-kilometre altitude where there's a transition of boundary layers. And in that little region, it's hypothesised at least that there could be probable life or possible extremophile kind of life there. So I just think it would be rude if you have the capabilities and the desire to just not have a crack. So I'm working very hard to put together a private mission to go to Venus in 2023, and we're going to learn a lot on the way there, and we're going to have a crack at seeing if we can discover what's in that atmospheric zone, and who knows, you may hit the jackpot. But at the very least, I think it's a needle mover even for just a private mission to go and try and do something interplanetary. I think that sends a message to the to the rest of the world that, hey, look, we can do these things privately. And if you look back through history, especially in space, actually, the first really large telescopes were privately funded. So we're not setting any new barriers here.
It's exciting to see the updates underway on the factory floor and with the engineering teams, as we're literally speaking right now. But it sounds like we need new T-shirts. Venus, it'd be rude not to.
Yeah, I'm up for that one. Yeah, it'd be rude not to. Absolutely.
All right, well, there's been about 200 questions, so let's get through some of those. Topical one. As you mentioned, we've just announced that we've increased Electron's payload capacity. Yep. What enabled that and why did we do it?
Yeah, so what really enabled that is, one of the governing factors with Electron is the turbopump and the power supplied to the turbopump. And we kind of bet on this, that battery technology would improve with time. And it just has. So for us to make a pretty remarkable improvement in performance, it's a battery cell substitute. So it's really not a big deal at all. So that's enabled it. And the reason why is, part of it is it gives us more capability to do more interesting things, but really it really opens a window for Venus.
Yep.
It opens a window for Venus, and it opens a window for recovery. So with recovery, of course, there's some negative mass growth there with the recovery systems, and this helps offset it.
Yep.
But it still keeps us in the really sweet zone. We think it provides the right cost point and lift ratio.
Because it brings me to the next question, which every person asks every time, is why aren't we building a bigger rocket?
Well, because there's no market for it, is kind of what we believe. And I think if you build a larger rocket, then you relegate yourself to being purely rideshare. And rideshare is really well served. You've got SpaceX serving rideshare extraordinarily well right now. You've also got the foreign vehicles, Vega and PSLV, and it's just a really cluttered space. So, if another vehicle is if we brought a rideshare vehicle to the market, then I think there's already plenty of capacity. We're not going to move the needle for anybody. Where we can move the needle is increasing the launch cadence of Electron and driving the costs down, so that people can use the advantage that the dedicated really provides. And that's where we're focusing on with recovery and things like that.
Okay, fun question here about what first got you into rocketry and what pushed you to start the company?
So for as long as I can remember, I've always been interested in space, and my father took me outside when I was very young. He would tell the story, and I would look up at the night sky and see all these stars, and once I saw a satellite moving over, and my father explained to me that was put up there by humans, and the natural question for me at that time was, well, are all the stars human made? And he explained to me, I'm too young to remember. He tells the story, but. He explained to me that all of these stars have planets and there could be somebody looking back at me. And that just blew my mind, like to think that, way out in the cosmos there could be somebody looking back at me. And I guess that's in some respects drives the Venus mission and really the desire to answer that question, is somebody potentially looking back at me, is life prolific or not? But I think space is one of those things where it's just incredibly attractive and inspiring, and it puts you in your place. You realise that you're relatively small and insignificant in the universe, and I think that to me is inspiring.
So that explains why you started with rockets, but Rocket Lab is not rockets alone anymore. You've mentioned, possibly regretting or rethinking the name Rocket Lab because we do much more than rockets these days. And why that transition into space systems with Photon?
Well, I mean, at the end of the day, what we're trying to do here is if you walk into a Rocket Lab factory, you'll see the first thing you read is, "We go to space to improve life on Earth." And that's not kind of some bloated CEO-y kind of buzz line. It's truly what I believe. And we launch access to space is obviously the key constraint.
But it's one part.
It's one part, right? So that's a key constraint. Now, once you have launch solved, you look across the ecosystem and you see, it's really difficult to build spacecraft and get them on orbit. And ultimately, what we're trying to do here is, get innovation ideas and businesses in orbit. So in order to do that properly, then you need to lower the barrier to build spacecraft, and you lower the barrier to operate spacecraft. And the definition of success here for me is all of that stuff is just pure commodity. The real value here in space is the ideas, the innovations, and the businesses you can build using it. Everything else is just a kind of giant pain in the butt. So you just need to remove all of that and let everybody focus on the things that add value.
Yep. So that means our customers just bringing their instrument or their sensor and us taking care of absolutely everything else.
Yeah, or their parts thereof. Whatever makes it easy.
Cool. Okay, and let's delve into some other questions. LC1 Pad B. So LC1A, home of all Electron launches so far, is going to get a neighbour. When's that going to happen?
Yeah, so Pad B is coming along really nicely, actually. If you had a look at, you may have seen a sneaky view of it in that recovery video. So all the civil works are done, and now we're just starting fit out. So So the erector will be arriving on site the next couple of months, and that pad will be operational by the end of the year. And what that gives us is redundancy, but also it just doubles our launch cadence straight off the bat, which is great. So being able to operate those 3 pads, really, it just solves any kind of range conflict or cadence issues.
Right, back to some recovery questions now.
Yep.
How do the parachutes on Electron affect the rocket weight, and is the return on investment good?
Yep, so that's a great question. So, when we're looking at recovery and looking at the various solutions, on a small launch vehicle, propulsive landing just doesn't trade. You end up building a larger launch vehicle. So we needed to let the atmosphere do the majority of the work. As a result, we see about 15 kg payload reduction in the vehicle. Hence the reason why we change these performance increases. It's around about a 15 kg payload hit for a recovery system. And is it economic? Well, I think our key driver here is increasing launch cadence. And look, if we can get it back in perfect condition and don't have to do too much work to it, then economically it's going to be great. But even if it just nets out even, it just saves a whole lot of work in building time and factories and whatnot. So and of course if it trades well, comes out on a really positively economically, then that's just great. We can pass it off to our customers.
Yeah, because we've got a question here about how many times a single Electron first stage can fly before we need any major refurbishment or to completely replace with a new stage.
TBC. I mean, we have to get one back in the factory and see how much work we've got ahead of us. Look, I'd take one right now. Just one reuse would be wonderful. But obviously, if we can get more reuses out of it, that would be fantastic.
Well, I think everybody's figured out now that we have fun names for our missions. So they've asked if we've already picked out a boat for recovery, and does it have a name yet?
Oh, what a good question. No and no.
I just see how excited you got at the prospect of naming a boat.
Yeah.
You guys might have started something.
There's a little bit, you have to be careful with naming boats because it's bad luck to rename a boat and all the rest of it. So I think we'll have to make sure we do that one properly. After Flight 13, I've become somewhat superstitious about things. So I think we need to
You mean Flight 12.999?
Yeah. Actually, that's a funny story. I banned the use of number 13. All analysis team had to use 12.999999 into infinity. That's not true, but at least it was an internal joke.
A whole lot of engineers terrified upstairs right now.
Yeah.
Okay, moving on to some career questions. So we've got some job openings at Rocket Lab right now, particularly in the space systems team. And those are in New Zealand and in the US as well, and across multiple sites. So what kind of advice do you have for people looking to join the team?
Well, I mean, look, you don't have to have worked in the space industry to join Rocket Lab. We have a really diverse workforce here. A lot of people from Formula One, a lot of people from automotive, of course, a lot of people from the space industry. But really what we look for are just really passionate people who are if it's an engineering role, born engineers. But we just look for people that have that burning passion and really want to do something significant with their life. Just not be happy with 9 to 5 and just a job. Like actually want to go home and talk to their loved ones, bounce their grandchildren on their knee. After they're retired and say, hey, look what I did. These are the people that we really want. And these are the people that excel at Rocket Lab, are self-starters that just want to own it.
Yep. No, I agree with that. Right, what other ones do we have, team? We've got some really good ones coming in here. Other than suggestions to call the boat Boaty McBoatface. Thank you very much. How many flights are we looking at in 2021 with all 3 pads operational?
So it'd be somewhat gated by production and market forces. So with the 3 pads, we can launch over 130 missions a year. But the market in this space is growing and will continue to grow for a while. So look, if we can get 20 launches away next year, we'll be happy. This year we had planned for 12. We got slapped with a pandemic and an anomaly, so that's slowed us down a little bit, not too much, but a little bit. So we'll still be trying to push out at least sort of 10 or 12 flights this year, and every year we try to double. by every metric. Double the amount of staff, double the amount of launches, double the amount of revenue. So, I think internally we'll be targeting sort of 20 to 24 launches in 2021. But the world also needs to allow that to occur.
Yeah. Yep. Some good questions then, talking on frequency. So, we want to be one of the most frequently launched rockets in the world, and last year we were number 4 globally. So that obviously raises a pretty good question about orbital debris and the responsibility that we have, both in terms of our rocket stages and our customer spacecraft, and kind of what we're putting up in orbit. What are our plans and thoughts around that?
Yeah, so this was kind of hard baked from day one. We've got a saying in New Zealand, be a tidy Kiwi, and that it kind of means don't litter in the national parks and whatnot. We apply that same thing to the way we go to orbit. So one of the key drivers for having a kick stage was that we could leave the second stage in a highly elliptical parking orbit. So basically we leave that in its home and transfer, and generally with about 4 weeks that second stage is burned up and re-entered. And then the kick stage, we're able to do those really fine insertions and then do deorbit burns on that and leave nothing behind except the spacecraft. But we adhere to the strict 25-year
It's far less
rule.
than.
But honestly, I think there's a much greater discussion that needs to be had globally. One of the issues that we've been facing recently is all the Starlink launches. When you get that freight train going, the last couple of launches we've had, I think about a dozen 3-second launch windows throughout the whole window, just to shoot up in between the Starlinks. So as LEO becomes more constrained with these mega constellations, everybody's worried about kind of on orbit mitigations and debris and collisions, which is fair enough, but equally well, creates issues on the ground where you end up with having these really, really short, almost instantaneous launch windows where popular orbits like sun synchronous and some of the more popular inclinations, 45, becomes really tricky to actually get launch windows that close.
I've got some fun ones in here. I'm trying to catch up with them. Can Photon double as a lunar lander?
I wish. No, we can obviously get to the moon with it, and we can get to Venus with it. And the interesting thing about Photon Lunar and Photon Venus is the spacecraft are basically the same. Everything that we've done to deliver Photon Lunar is in the mind of delivering Photon Venus. So really, there's very almost no difference between those two spacecraft. But to the moon we get sort of 37 kgs. So in the spacecraft itself, just doesn't have the delta V to scrub and then land. But there's an interesting opportunity for a micro loon lander there. Somebody think they can do that with 37 kgs and get a small payload on the moon. Photon will be around orbit as a comms relay. So it'd be fun to see someone try and do that.
It's the exciting thing about Photon is it just opens up so many possibilities for us beyond launch. Just huge set of capabilities.
Yeah, I guess I'm more excited about the fact that, for a relatively small, tens of millions, 10, 20 million, you can go to Mars, you can go to the moon, you can go to Venus on your own dedicated mission. I think that's, from a scientific standpoint, that's the thing that excites me a lot, is that, generally if you want to do a science mission to the moon, start writing a check at $50 or $100 million. For $10, $20 million, you can actually do some really good science, interplanetary and lunar. That's what excites me.
So we're getting a lot of questions about Capstone here, so I'm just going to wrap it all into one, which is tell us what Capstone is, how we're going to achieve the mission, and kind of where we're at development-wise at the moment.
Yep. So the mission design is actually pretty complicated. So it's not up and direct inject. So we go up into a relatively low orbit, and then we start a whole lot of orbital phasing burns. So I guess I should roll it back a little bit. And Capstone is a NASA-funded program to deliver a spacecraft into cislunar orbit. And our part of that role is to put the spacecraft on a really nice lunar trajectory, and then they spend a bit of time circularizing around the moon. So it is, in order to do that, like I say, it's not a direct inject. We go up, we spend many days in orbit, and every couple of orbits we do an orbit raising maneuver, and we slowly lift the apogees and the perigees, and then we do there's a set of 8 maneuvers, so a lot of on-orbit maneuvering, and then and this is primarily to reduce the energies required to get to the moon, and then we do one last TLI burn, and it's on its way. And so is Photon at that point to the moon.
Because what happens to Photon after the spacecraft separation?
Well, in theory, our job is done, but I've tasked the team with let's go and get a really sweet shot of the moon with a lunar flyby. So that's kind of a secondary stretch goal, but we're going to try and whistle past the moon and get some selfies.
That would be incredible.
Yep.
All right, back on Earth a little. Have we ever considered multiple fairing variants for Electron, which is perfect timing because we actually did release a new payload user guide yesterday, which does have options for expanded fairings for larger spacecraft. Do you want to talk about why we did that?
Yeah, I mean, if you've increased your mass, you may as well increase your volume at the same time. So, yep, the answer to that question is yes. Yep.
Easy. Right. Do you plan to fund more private missions besides the Venusian Photon mission?
Well, I haven't really
tackle that one first.
Yeah, I mean, I don't know. Searching for life on Venus, it's not trivial. So perhaps, I mean, I'd love to kind of throw the baton out to everybody else as well. And if we can create this capability, then I'd love to see a lot of private science missions. Like I said before, I think through history, some of the greatest explorations have been private, whether it be some of the early South Pole expeditions, and certainly if you look through history, astronomically it's littered with privately funded missions to do things that it just takes too long for governments to iterate on. And then the challenge with government missions, of course, is that you have to take politically acceptable footsteps.
Yep.
I'm looking for a great big swing here. This is a big shot, and it may work and it may not, and that's fine.
And that's commercial's role to play, right?
Yeah.
Taking on that risk.
Yep.
Now we have a very, very important question here from Scott Manley. Thanks for joining us, Scott.
Oh, hey, Scott.
And it's disappeared. Here we are. Can we get Rocket Lab logos licensed for Kerbal Space Program along with the small electrically pumped engines? I feel like I decide that, so yes.
Yeah, I don't have a problem with that. Yeah,
that sounds fun. Let's do that.
Yeah.
Okay, one from Tim Dodd, the Everyday Astronaut. He's watching as well. Are some of those limited burns from limited thrust from hypercurie or from battery capacity or recharge rates from solar? This is referring to the Photon. Yeah.
So actually, Tim, I just want to noodle on that a little bit because the really cool thing, so hypercurie is kind of the next evolution of the Curie engine that's currently on the kick stages that we fly. So we have a monopropellant version, a bipropellant version, and then hypercurie. And hypercurie is a hypergolic version of the propulsion system. And it's electrically pumped, so we've used that technology and those learnings. But the really cool thing about an electrically pumped spacecraft propulsion system is that normally with a launch vehicle you're limited by your battery capacity because there's no harvesting electricity on ascent. Whether in a spacecraft you've got plenty of ability to harvest electricity, so you just don't need to keep all of those massive reserves of nitrogen for pressurized systems, blowdown systems. So you end up carrying, it ends up being super efficient. I think of all the use cases of electric pumps, an on-orbit spacecraft propulsion system with a decent kind of impulse is the best by far, because you basically, get that pumping energy or that pressure energy for free from the sun. So that's super cool. That's what I love about the hypercurie. What was the rest of the question? I'm just super excited about that bit.
Oh, Tim, you lost me. We're way up here. Are those from limited burns with limited thrust from hypercurie or from battery capacity / recharge rates from solar?
Yeah, no. So the burns aren't limited. The multiple burns. The reason why we do multiple phasings of the orbit is to get to get to the moon. It has to be bang on. Like there's no kind of we're half a kilometre out here or few fractions of a degree. It's got to be bang on. It's a long. The TLI burn has to be just right. So what we do is you do one phasing burn, and then we have ranging radios on board where we pull back all the orbital elements and we go, okay, this is where we ended up. and then we do another one, and we just sneak up on it, burn after burn after burn, until we get it just absolutely bang on. Yeah, because you get that little bit wrong, then you miss the moon by a mile.
Okay, from the moon back to recovery, are we going to attempt to recover fairings?
No, we did. We took a good look at it, but the cost for us to build a fairing, we spend way more in diesel looking for it in a boat. A fairing, to give you a sense of scale, like a fairing, an all composite fairing, its mass is about 15 kgs per half, so 30 kgs total of fairing, monolithic structure, all in autoclave, pre-preg molded, and I think a fairing costs us $20,000 or something like that. So it's just not worth it.
Yep, that makes sense. A question more on kind of the overall market. I think we had the first hot fire of Rutherford in 2013-ish.
Yeah,
would have been about
2014 was around about then.
Yep. So from then to now, how much has the customer market changed? What kind of changes are we seeing from our customers? How are their needs evolving? Is Electron still meeting their needs?
Well, I think when we first started this, spent a lot of time analysing where we thought that sweet spot was going to be, and I think that's kind of proven out with the capability that we've been able to throw in orbit. But certainly back then it's very much build it and they'll come. Clearly there was a market opportunity. And it's one of those things where you create this opportunity, and then that helps grow the market. But I think it's fair to say that the market is growing at the trajectory that everybody anticipated. But of course we'd love to see the market grow even faster, and part of that is providing more launch opportunities at lower price.
Absolutely.
I'm amazed nobody's asked why the parachute is a ring sail rather than a ram air.
Please, regale us.
Honestly, I thought that was going to be...
I genuinely haven't seen a question come through on that.
I thought that was going to be the first question, and the answer to that is, for this initial recovery attempt, we're not aiming to try and scoop it with a helicopter. We are, we just want to get it down to the ocean surface safely, so we have no guidance requirements. So a ring sail gives us more control over that.
Were you in the helicopter for the drop?
No.
You're going to catch one yourself?
I'm not that good. I'm just happy to land.
I think we all are. Will we ever fly Photon on a different launch vehicle? So not an Electron, not a Rocket Lab vehicle?
Yeah, I mean, I don't really have any particular issues with that. If it's great, if it's a great project and it's exciting and it moves the needle for a customer, Photon has, especially Photon Lunar, has an enormous amount of Delta V on board, and it is designed from day one to be an interplanetary spacecraft. So if somebody wants to use that and go further afield or do something more interesting with it, then yeah, absolutely.
And I have to ask,
have to have big Rocket Lab logos on it though. Like if it's going to fly in someone else's rocket, I just want to make sure it's got big Rocket Lab logos on it. That would be the only stipulation.
Lose some mass just to logos,
Yep.
Okay, lots of questions here about... You guys keep asking about bigger rockets. We've talked about it. Are we going to be able to stream the whole of Electron's return flight until capture after a launch? Probably not Flight 17.
Probably not Flight 17, and the logistics there are, the tracking stations, getting we can get the data, into aeroplanes, because we have aeroplanes on station and boats on station, but getting them off aeroplanes and into a live stream, that's where the logistics become a little bit more tricky, because we have to have a secondary link back up to Optus or some other GeoBird that we can pull it all through, and then the bandwidths get pretty crazy. We will have live telemetry, so we definitely have live telemetry because the bandwidth is not as crazy as HD video. But
because we have got some video from previous attempts, but it's...
Yeah, so the reason why we had video in previous attempts is we were running we were able to live stream as we were running a different trajectory that was closer to our Chatham Islands ground station. So we're able to pick up the link in Chatham Islands, and the Chatham Islands already has a geolink back to mission control. The Flight 17 trajectory is running a bit further south, so we don't have that over the horizon on that link. But look, we'll make sure that there's going to be lots of cameras on board. So if it's accessible,
we love a video.
Yeah, yeah.
Okay. What about heat shields on recovery vehicle?
Yep.
A lot of questions about that.
Yep. So on the bottom of stage 1, because we have 9 engines, there's a lot of plume-plume interaction between those engines and a lot of base flow recirculation. So the heat shield on the bottom of stage 1 is already pretty beefy. It's like an inch thick of TPS. So there's a lot of thermal control down there. On the re-entry flights, we had the heat shield instrumented with heat flux sensors, and we got a pretty good idea of the environment there. And it's pretty hot, to be fair. It's pretty nasty, and there will need to be heat shield upgrades, absolutely for sure. But we've just left the heat shield as it is, and we know from the telemetry that the heat shield does collapse around the engines, and that's just kind of fine. But I think it's more valuable to get it back, and when you're kind of in an ablation regime, it's really difficult to measure the depth of the ablation. So the easiest way to kind of work it all out is just to get it back, put it back in the shop. You can look at the way it's failed by understanding some of the loads.
It's the way we test, isn't it? We just try it, refine it, see how it goes.
Yeah, I mean, we could spend a bunch of time in analysis trying to figure out exactly the dynamics of all of that. And because we're going in blunting first and we're propagating that shockwave forward of the engines, there's all kind of weird flows and shockwave attachment points. So it's really, really tricky to model, and I think we'll learn a lot by getting one back, and that'll inform us, inform all the models, validate the models, so that we can make design decisions from there onward. And it's a bit of a tricky one, because you need to balance between just going in testing blind and getting no result, versus doing enough analysis up front to work out actually you're going to get the right result.
Yeah. Here's a fun question that I'm sure is going to be in dispute throughout this company. What mission name was your favourite?
Oh, actually, this one's for Pickering. This is a NASA VCLS launch. That mission was very personal for me, because as a child I grew up watching NASA TV, and I still have a little model of a space shuttle that was given to me a very, very long time ago, sitting on my desk, and it was always a dream, to work for NASA, to be able to fly them with our own launch vehicle was really good. And on that launch we had so for you guys who aren't familiar who Pickering was, Sir William Pickering was a New Zealander, and he established, or helped establish, JPL, and there's a famous photograph of Von Braun and William Pickering holding up Explorer 1, US's first satellite, and William Pickering was heavily involved in that. So it was a bit of a nod to that, but also we were able to have a whole lot of his family here to watch the launch. So we had a whole lot of Pickerings in mission control. So for me, I think that name and that mission meant a lot.
Another good question here. So we've got the 3 launch pads at the moment, so LC2 and then the 2 pads at LC1. Is that going to be enough for us for the foreseeable future, or do we need to go somewhere else?
No, I think that's plenty. I mean, we can achieve an inclination from 37 degrees through to sun synchronous or retrograde. So the only inclinations we can't achieve are 0 to 37, and zeros are kind of, those really low inclinations are kind of more useful for geo spacecraft. We haven't really had any customers that are looking for those super low inclinations, and those 3 pads give us over 130 launch slots a year. So that's plenty.
That, and really don't want to build another pad.
No, although I have to say, LC1B
we've got faster every time.
Flying together, and the guys, after they built, the whole team rolled straight off LC2 onto LC1B, and it's just a printing press for launch sites right now. Yeah,
that's a good way to describe it. We get weekly updates from the team, and every week the photos from these drones look completely different. How are you packing in this much every week? But it's hugely, hugely exciting.
Those guys know how to build a launch site, that's for sure.
Speaking of launch sites, someone's asked, did we ever consider air launch?
No. Not really. The kind of the challenge with air launch is if you look at the what you get from the performance increase first off, that you get from an air launched vehicle is around about 3%. So where air launched vehicles are typically being launched from with their altitude and their velocity, I think we're about 15 seconds into flight and we're at the same, if not higher velocity and higher altitude. So it's only a 3% gain. The whole reusable first stage thing is kind of a bit of a fallacy. So for 3% gain, you do trade a lot of complexities, and it's a lot to put people on your rocket. And at Rocket Lab, the nearest person is 3 kilometres away when we start Locksville, and I don't know. I mean, if you've got to return back after a launch and say nobody died today, then that's not the place you want to be, in my opinion. And there's a lot, but there is. Look, don't get me wrong. There's a lot of advantages with air launch as well, with respect to to being able to go to different inclinations. But if you've got a launch site that can swath a whole lot of inclinations, then you kind of nullify that as well. But and the challenge with that is that even when you go to a different inclination, you still need telemetry, you still need range safety. So all of those things don't go away. You still end up picking launch sites that have ability. You have access to cryogens, access to you still got to runway flight safety corridors, and you still have to have telemetry and all of those things to be able to make a mission successful. So there's a lot of constraints there, but I think, and there's some advantages for sure. But for what we were trying to do, it just didn't trade that well.
All right, well, we're starting to go, well, not overtime, we didn't set a time, but I think maybe we'll take 3 more, so get them in. How are the Rocket Lab sheep doing? They get pretty close-up view to launch.
They're surprisingly content now. Same with the cattle.
You can see the ones right next to the launch site, and they get out of the way, and then the ones a bit further back just kind of keep chewing. Yeah, no, it is the farmer runs an operational farm around there, and there's the cows. The first couple of launches, they sort of wonder what's happening, but now they just sort of look up and then look back down. Even when we were doing the drop tests a couple of days ago, it was obviously it's an active farm, and it's just helicopter ops. There's helicopter ops happening there every day. So got the best view in the world.
Yeah, it's pretty normal.
Cool. Okay. Internships. Lots of people asking about internships. Is there a chance for high school internships with Rocket Lab in the US or in New Zealand? I think at the moment we're only taking tertiary, so quite senior students. Yep. We do have some education programs with high school students and younger students than that as well, but in terms of internships directly, that's all at that tertiary level. Yeah. Yep.
And that's primarily because I don't believe in giving an intern a job of sweeping the floor. Like if you're going to be an intern at Rocket Lab, you're going to get real work. And you need a base level of experience and education to be able to tackle the kind of tasks that we're going to throw at you.
Well, because let's talk about that. I mean, the internship market is incredibly competitive, and there are some fantastic candidates out there. And so many people come to us with incredible resumes and great, kind of scores. What is it that we look for in an intern that makes them stand apart?
Yeah, I mean, and this goes really with anybody we employ at Rocket Lab is a generic kind of CV that has your grades and all the rest of it is kind of irrelevant to me anyway. What I'm looking for is what do you do outside school, and what do you do outside work.
Yep.
There is absolutely a common magic here that the best engineers typically are born in that way, and they have lots of engineering passion outside. So if you get 100 CVs, they all look the same. What we're looking for are what have you done. First of all, just what have you done, and sometimes it doesn't even need to be engineering. Like just show us
build a business. Have you?
Yeah, just show us that you just get stuff done. And so I always encourage students, especially, look, your education is important, but what you do outside your education is equally important. For people like us, we want to see your commitment and just take on a project and run it to ground and execute on it. I think university is great at teaching how to learn, but in industry, it's really about execution.
Yep, absolutely. Right, team, I'm going to look for one more. So last time to get them in.
There hasn't really been any stinkers. Is there a real stinker in there?
What's the worst thing you can throw at us, guys? People asking if we're going to do propulsive landing. I feel like we've addressed that for reasons.
Yeah, it just doesn't trade for a small launch vehicle. You end up, you need about a third residuals of propellant to do that effectively.
Yep. Okay. I'm going to ask you some quick fire, maybe yes or no ones.
Right,
Let's just
sounds
run
good.
through some of those. Okay.
Yep.
Okay, can't read that one, so we're not going to go quick fire on that. Real slow fire. Are you going to do any STEM programs to inspire younger students? Yes, we already have them. I'm going to answer that one. Go to our website and contact us.
We've done over 80 internships
Yep.
and apprenticeships to date. So, it's super important. Look, talent is incredibly constrained. Like, one of the biggest throttles for Rocket Lab has always been access to great talent. So, we do apprenticeships, internships. There's been 5 PhDs that were sponsored, master's students. We just look for raw talent and then try and get in behind it. So, I think, quite frankly, it's everybody's role within this industry to grow new talent.
Do you ever get tired of launch days? We've done enough of them now.
I'm terrified on launch days. I thought by the time we got a few more under our belt that it'd become really enjoyable. But every launch day, you're only as good as your last launch, and every launch day I'm very, very focused.
Not a lot of sleep the night before.
No, launch day. Every launch day I write off at least 2 days of potential sleep. That's for sure.
How many explosions did we have in rocket development?
I'm not big on explosions, to be honest with you. Explosions are really expensive. Early Rutherford testing, we blew up the test cell, we blew up engines 3 times in probably relatively spectacular ways. But really, that's been it. And that was that was very, very early on as we were learning kind of the pluses and minuses of electric pumps and basically to do with ignition delays and timings. But yeah, so I think our approach at Rocket Lab is kind of, I would say, in the middle. So if you look at, there's one spectrum where you just do heaps of analysis and you do everything in simulation, and then you build one piece of hardware and you expect it to work. And then the other end of the spectrum is where you just throw mud at the wall and just keep on throwing mud at the wall until something sticks. I like to think that the most efficient place to be in that development curve is in the middle, where you do a bunch of analysis and small-scale tests, and it's okay for the small-scale tests to fail. That's the whole point of it. And you learn and iterate. But really, when you're getting to full-scale tests, as opposed to sub-scale tests, you really don't want those failures because they become very expensive and slow things down a lot. So, I think where we try and strike the balance is, yes, we have a fail-fast mentality, but fail fast on sort of sub-scale and the small stuff. But when we get to full-scale, we really don't expect to fail. And I guess that's best evidenced by Electron's track record of how fast we went from a test flight to entering service. Is we built a vehicle that we intended to be a full commercial vehicle. There wasn't intended to be a test flight and then a whole lot of development and ease our way into it. We tried to bring to market a vehicle that was the final product. So that really enabled us to go from one test flight hooking straight into commercial ops. And to be honest with you, the vehicle has not changed.
That's what people have been asking a lot
little.
is how much has changed, and we've had this performance upgrade,
Yep.
Reusability,
Yep.
but really we set out from day one with a vehicle we wanted to build. And
yeah, and a lot of thought given to production constraints and requirements, and a lot of the designs around the vehicle, segregating off the bottom engine power pack to the main tank, so that we could build that module, concurrently with building tanks. And we do the same with the interstage. It's a separate module, so people can work on the interstage, and then it's a sort of a come together at the end. So a lot of thought went into production. And if I look across the vehicle, of course we've done a lot of things to improve reliability and production and things like that, but really the vehicle really hasn't changed. And Rutherford engines, are probably the thing that's changed the least. They really have, we've made a lot of refinements and improvements, but physically there's been no changes really.
All right, you asked for a hard question.
Yeah, okay. Well, I didn't really ask for one, but I was just surprised.
Oh, you ask and you'll get.
Okay.
Which competitor scares us most?
Well, firstly, one that flies. Let's see someone put something in orbit. Until something's gone in orbit, it's kind of an emerging competitor, isn't it? And there's a big line between trying to get to orbit and getting to orbit. And
as we found, there's a big line from first mission to regular reliable launch cadence as well. That was harder than first mission. Yeah, that's hands down.
That is huge.
Yep.
But look, I'm spurring everybody on. I think it's great that there's a lot of activity in this industry, and there's a lot of competitors. That keeps everybody sharp. I love a good competition. So having a bunch of competitors keeps everybody sharp. I think it's great. And there's quite a diverse range of approaches and technologies, which is super cool. And look, there's going to be a bit of a day of reckoning at some point, and that's fine. But at the very least, I think there's going to be some really cool technologies developed, approaches developed, and ultimately, it's going to push the state of the art further forward. And take a holistic view as a kind of a human species thing. I think it's just all great.
Yep. Very last question. Are we going to build a different engine?
Well, I mean, no immediate plans. I mean, the Rutherford has just been an incredibly reliable workhorse. There's 130 of them gone to space, and we've built over 200 of them now. It's just a wonderful formula for a small launch vehicle. So there's no engineering nor commercial reason to exchange Rutherford with something better, because it's going to be hard pushed to put something better under that vehicle.
Yeah. All right, well, thank you for joining us. I think that is more than enough and more than we had time for, really. But that was a lot of fun. I enjoyed that.
Yeah, no, it's great. Yep.
What I will do is I'm going to flood Peter's Twitter threads. So if you've got questions we didn't answer, go and ask him on Twitter. And when he's got a break between packing parachutes or flying helicopters to the launch site, he might be able to answer them for you.
Great, thanks Morgan.
Signed you up for that.
Thanks.
Cool. All right, well, thank you so much for joining us. Sorry we can't be there in person in SmallSat this year. We really hope to be there next year. And if this was fun, hey, maybe we'll look at doing another one.
Yeah, great. Thanks very much, team.